We arrived at this distinct shape based on the structural, functional, and programmatic relationships. The sleekness of the design is intended to minimize the dust storms that may come along. Our unique solution, located near the equator of Mars, starts out with the arrival of the spacefaring module, whose exterior shell splits off as it lands similar to the Curiosity rover, leaving behind a prefabricated core. After landing upright on the Martian surface, the 5-axis print arm extends from the top of the core and prints a foundation and footing layers utilizing materials found on the Martian landscape. Immediately following the completion of the foundation, the print arm will transition vertically to begin printing a concrete shell. Secondary print nozzles will begin printing HDPE layers on either side of the concrete, effectively sandwiching the Martian concrete in the middle. A portion of the shell construction will give way to the equipment hatch, allowing for connection to future habitats. When the shell construction reaches the height of the laboratory level, floor plates and supporting structural members will deploy from the pre-manufactured core, which will rest upon the newly printed shell. If desired, a slab layer can be printed on top of the plates for a cohesive floor. The shell construction will continue progressing upward. Daylight will be allowed into the habitat by means of reducing or eliminating portions of the central concrete layer in the exterior shell makeup to have just the HDPE layers as the skin. The location of these daylit portions will strategically correspond to programmatic elements of the habitat and will highlight the intricate nature of 3D printing capabilities and parametric modeling. The grade level will contain the access to the SEV and connections to future habitats. Access occurs from a floor hatch in the airlock. A garden area is located outside of the foundation wall area and accessed from the laboratory level. The design of an oblong projection in the shell allows for a great deal of daylight for gardening and food production. The medical exam and procedure room, along with an emergency shower, are located nearby should any urgent action need to occur from outside the habitat. The lab is located adjacent to medical. Next to the lab is the communications room. We then have a stair that leads to the living level and one that leads down to the ground level. Next to that is the garden room that can be used to grow plants from seedlings, as well as plants that require different environmental conditions than the ones out in the light at grade. After the lab level is complete and the shell reaches the height of the living level, another set of floor plates will deploy, and the process will repeat until the habitat reaches its terminal height. On the living level, we have 4 uniform bedrooms, a recreation area, a dining wardroom, and an exercise area. The food prep and storage areas will be built into prefabricated core. Besides the stair that goes down to the lab level, there also will be ladder access to the floor above. The upper level will house the 3D printing operations and storage. When complete, the pre-manufactured core will contain all of the plumbing, ventilation, and life support equipment required for the duration of the astronaut's stay, including toilet facilities, a kitchen, and laboratory hookups as required. Communications equipment will be pre-wired into the central core and will extend through the shell near the top of the habitat.